Okay, last topic for this chapter in honors chemistry, we're going to talk about percent yield. So whenever a person goes to lab, they get a certain amount of product. So that is their actual amount. And they could, to find out exactly what they could have gotten, you can do a stoichiometric calculation, and that tells them in theory what they should have gotten. So then to find your percent yield, you take what they got divided by what they should have got in lab times 100. Okay, so chemists are interested in comparing the actual amount of product from a reaction, so actual amount is what they got in lab, with the amount calculated by a mass calculation, which is their theoretical. So theoretical says, in theory, if life were perfect, you should have gotten this. So your formula is percent yield is equal to actual yield over theoretical yield times 100. And for percent, once again, I would like for you to carry those answers to 2 decimal places rounded correctly. Okay, so here's our first problem. It says you started with 1.75 grams, so I like to write stuff above where that belongs, and excess methanol, so you just have more of this than you needed, and you calculated the maximum yield to be 1.93. And then after the reaction is run, you find that you only got 1.43. So what it's saying is you should have, in theory, got 1.93 grams of this. And you only got 1.43. Okay? So what's your percent yield? So percent yield is equal to actual over theoretical times 100. So that's equal to 1.43 grams over 1.93 grams times 100. Your grams will cancel. So 1.43 divided by 1.93 times 100. So that means you got 74.09%. So you got that much of your product, or you can look at it this way, you lost 26% of your product. Okay, the next one, the actual amount of a product in a reaction is 39.7 grams, although a mass calculation predicted 65.6 grams. What is the percent yield? So percent yield, once again, is actual, which is 39.7 grams, divided by, in theory, you should have gotten 65.6 grams times 100. Grams will cancel. So you're going to say 39.7 divided by 65.6 times 100. So you only got 60.52% of your product. So basically you lost almost 40%. Okay, next one. It says, what is the percent yield in the following reaction if 5.5 grams of H2 reacts with N2 to form 20.4 grams of ammonia? So you have enough stuff here to write a balanced equation. So you're going to say H2 plus N2 yields ammonia, which is NH3. We're going to put a 2 here to balance. We're going to put a 3 here, and now we're balanced. Okay, so we have 5.5 grams of H2, and we went to lab, and we got 20.4. Okay, so if you have a number over a reactant and a number over a product, and it's a percent yield, that means you're going to have to do stoichiometry. So we're going to do stoichiometry, and we're going to find out if we have 5.5 grams of H2, in theory, how much ammonia should we have gotten? We got 20.4, but let's see what we should have got. So we're going to say 5.50 grams H2 times there are 2 grams H2 in 1 mole times for every 3 moles H2, you have 2 moles NH3 times in every 1 mole NH3, there are 17 grams. Grams H2 cancels mole, so we're going to get grams NH3. So this is, in theory, how much ammonia we should have gotten. So 5.5 times 2 times 17 divided by 3 divided by 2. So in theory, we should have gotten 31.2. We got 20.4, so you take your actual, which is 20.4, divided by your theoretical, which is 31.2 times 100. So your percent yield is you got 65.38% of your product. Okay? Okay, next one says, assuming a 79% yield, how many grams of hydrogen are required for the production of the 30.8 grams of ammonia, assuming excess nitrogen? Okay, so once again, balanced equation. Okay, so this one's a little bit different in that you went to lab and you got 30.8, but you only had 79% yield. So there's two ways you could work this, okay? So keep in mind that percent yield equals actual over theoretical, okay? So we have our actual and we have our percent yield, so we want to find our theoretical. So we could say theoretical yield is equal to actual over percent. So you actually got 30.8, but you only had 79%, so I'm going to do 0.79. So that means we 38.98 grams of ammonia. And now I'm going to take my 30.98 grams of ammonia, and I'm going to, or I guess that's 99. I'm going to go backwards and find out how much hydrogen I needed to give me that many grams. So I'm going to say times 17 grams NH3 and 1 mole NH3 times for every 2 moles NH3 to 3 moles hydrogen times 1 mole hydrogen gives me 2 grams hydrogen. Okay, so I'm going to leave that in and calculate 38.987 times 3 times 2 divided by 2 divided by 17. Okay, so that means I will use 6.88 grams of H2. That's one way of doing it. Another way of doing it is you could just take your 30.8 grams of ammonia, so whichever way makes more sense, 17 grams of ammonia in 1 mole times for every 2 moles of ammonia, there's 3 moles hydrogen, times in every 1 mole of hydrogen, there's 2 grams. So this says if I had 30.8 grams, if I produce 30.8 grams of ammonia, I'm going to need 5.43 or 5.44 grams H2, but I'm only going to get 79% yield, right? So I want to find out what my theoretical is, so I'm going to say 5.44 grams divided by 0.79, because I'm only getting 79%. And once again, it's 6.88. Okay, so you can do whichever way makes the most sense. All right, thank you, and that completes the information on this chapter. Now you can do your percentage composition, your percent yield homework.